All right, so this is our new unit on probability. Our goals for today are to find the probability of independent events. That means one event does not change the other. And also to contribute to class by asking and answering questions. Good morning. We have a short video, and I'm going to pause this because I'm not going to put the video in the video. So you can either get to your student.desmos.com activity by typing in that address and then using a code, or you can click the link that are on the slides in Schoology. Again. Okay, so simple probability is the number of favorable outcomes over the number of total outcomes. So if I wanted to know, looking at this bag of marbles here with red and blue, I know that on your black and white copy, it's hard to tell red from blue, so I tried to make like R's for red, and I tried to make B's for blue. If you look at your piece of paper there, it's right there. So if I want to know the probability that I choose a red marble out of that bag, it's going to be the number of red marbles divided by the total number of marbles. So if I count them up, I see I have 7 red marbles out of 12 marbles altogether. So the probability of red was 7/12 and the probability of blue is 5/12. You can also express probability as a decimal if you divide them, but you don't have to. All right, so let's take a minute and answer example 1 and then compare your answer with your neighbor. What is the probability that the spinner will land on number 2? So you're going to write that on your paper. Okay, so the probability that we get a 2, how many 2s are there on the whole spinner? One, two, three. There are 3 2s out of how many spaces altogether? 5. Good. So on your paper, you should have written the probability of 2 equals 3/5. If you have something else, let's make a correction. What questions do you have on that first problem? All right, this one's not on your notes because it's nothing to write down. It's just something to think about. If you get a probability that's close to 0, that's going to be very impossible or unlikely. But if you get a probability that's close to 1, that is going to be certain or very likely. So for example, a probability of 4/5, that is going to be up here with the likely to happen. A probability of 1/5 would be down here with the unlikely to happen. So I just want you to think about when we get these numbers, like what do they mean? If it's a high number close to 1, it's going to probably happen. If it's a low number close to 0, probably not going to happen. All right, so we're going to look at the coin flip here, and this tree chart is showing you what you could happen with 2 different coin flips. So when you flip it the first time, it could be heads or tails. And then after you get heads or tails, you flip it a second time, and it could go heads, heads, or it could go heads, tails, or tails, heads, or tails, tails. So these are all the different outcomes you could get. So if I want to know the probability of any of these outcomes in particular, so say I want the probability of getting heads, heads, you multiply the probability of the first one times the probability of getting the second one. So we're going to use that idea here for example 2, and we'll just do this one together. If I roll a die, and here's a die over here, what is the probability I get a 5 on my first roll and a number less than 5 on my second roll? So how many sides are on a die? 6 sides on a die, good. So 6 sides on a die, only one of them has a 5, so the probability that you get a 5 on your first roll is what fraction? 1/6. Is he right? Anybody want to agree with Dion? Raise your hand if you agree. Good. All right, so the first one is 1/6. I'm going to put parentheses on that because I can't make like the pretty fractions on here. All right, times, all right, a number less than 5. So how many numbers less than 5 are on the die? 4, yeah. 1, 2, 3, 4. Very good. So 4 out of how many sides altogether? 6. All right, you guys are doing really good with this. So 4 out of 6, like that. All right. So just a little review of fractions. Go ahead, Nadine. Oh yeah, it is times. I made a little star there for times. Thank you. So you're going to multiply the 2 fractions to find the probability that they both happen. A little review of multiplying and adding fractions is on the right board there. To multiply fractions, you don't need to worry about common denominator. You just multiply the numerators, and then you multiply the denominators. So I'm going to do 1 times 4, and what do I get? 4, good. Oops, I put that in the wrong place altogether. 4, and then 6 times 6. 6 times 6 is 36. Good. Now I'm going to pause my video to show you how to do this on Desmos, and I have to pause my video because it will look weird if I try to record it there. Okay, so you can either do that by hand or with Desmos, and you can get that this fraction simplifies to 1/9. All right, so let's think about that for a moment. Does that seem like it is unlikely or likely to happen if your fraction is 1/9? Unlikely, good, because 1/9 is closer to 0 than it is to 1. 1/9 is small. 8/9 would be very big. 1/9 is very small. So this is unlikely to happen. And I'm just adding that note there so I can remember that every number can be interpreted. All right, so we have this bag here, and if you turn your notes over, I tried to label them for you, but it didn't copy very well if you look at it. So just look at my picture for the moment. Here's my picture. What's the probability I choose 2 green marbles in a row? And it says with replacement. That means that after I take a green marble out, I put it back in. Okay? So the first one would be, how many greens do I have? I have 4 greens out of how many altogether? 4 out of 10, good. So the first one would be 4 out of 10. And since I put that green marble back, I do another 4 out of 10. And I'm going to multiply the numerators and the denominators. And then go ahead and simplify that fraction. The other thing you could do is make it a decimal. I really am fine with both simplified fractions and decimals. Okay, the next question is interesting because it's similar but a little bit different. What's the probability I choose 2 green marbles in a row? Oh, that says with. That's supposed to say without. Can you guys fix your paper too? Because I just copied that from on your paper. So this one should say without. So fix that on your paper too. Part B should be without. So the probability I choose 2 green marbles without replacement. So what happens is the first one's going to be the same, 4/10. All right, but then I took one of those out, so I'm going to mark it off. Okay, that's gone. So now I only have how many green left? I only have 3 green left, and I don't have 10 marbles altogether. I only have how many marbles altogether? Do you guys see that? I took a marble out. So now I only have 3 green out of 9. So I just get a slightly different answer. It didn't change a whole lot, but it did change. So I've got 4 times 3 and 10 times 9. So when it says without replacement, that means that when you take the green marble out, you don't put it back in. Because it says the probability I choose 2 green marbles in a row. So first I took 1 out, that's the 4/10, but I took it out, it's gone. And then the second time, there's only 3 left. All right, so we are going to stop here for a moment, and we're going to do some partner problems. If you're sitting next to somebody there, your partner, if you're not sitting next to somebody and you know who you want to partner with, you can move yourself. Otherwise, I'll move you.